Today's job is to fit this solenoid into our project for a dual battery system. But the problem we have, it's Sunday morning, most of the shops are closed, and we need to fit this solenoid. Now ideally, in an ideal world, I'd like to put just some big self-tapping screws through here, but I haven't got any. And of course, in their infinite wisdom, when they've put the bracket on, instead of putting it a little bit lower so you can get a drill, you know, straight down there and into it, you can't really get in. So what we're going to use is captive nuts. Now these are, in North America we can't simply get metric stuff, so you'll have to bear with me, but these are 1/4 20. It would be equivalent of what, a 6mm. Like I say, we haven't got one and I can't find the stuff anywhere. Well, I can get plenty of captive nuts sort of thing, well, but they come from England and, well, wait a minute, I'll show you what they're like. They're like this. They've got a hexagonal shape on them which goes inside the chassis of a Land Rover to put the steps on. And look, there's another one. They're hexagonal, so, well, I haven't come up with a hexagonal drill yet, so I'll have to wait. So what we're stuck with is domestic ones which are useless. Now this little tool here is a commercial tool for putting captive nuts in. It's almost like a pop rivet gun. And what happens is that when you pull with the handle, it stretches or compresses this nut. But this is so worn out. I mean, if you want to get one, I mean, they're alright, but they're not very well made, and after about 10 years the damn things wear out. It should be a British one made of cast iron that you can't pick up, it's so heavy. But anyway, idea is you screw your piece on there and then you put it through the piece of material, pull the handles together, but as you can see it's already on its stop, so this is now defunct. It doesn't work. I'd like to buy a newer one, but they are kind of expensive. So what do? Well, thanks to here at Britrest, we haven't come up with this idea, but it's been around for quite a while. What we do is we simply get an existing bolt, and now, of course, 1/4 stuff here is just like, we never use it really, but sometimes at the hardware shop that's all you can buy. And this is the only one I've got in stock, and it's got a plain shank at the top, so I'm building it with all bits of washers that I've got. But what I've got here, if you can see there, is a 5/16 nut or an 8mm nut, and I've put some chisel marks in the top, and there is a reason for that. See, when you slip the nut on like that, it will grab onto the head, because what will happen is, as you're pushing this, as you're trying to compress this, because this will do the same as the tool, as we tighten up the bolt we want to keep this in place. So what we do is we put a spanner round this old nut here, this 5/16 nut, and we're going to turn this here to compress the captive nut. Now I'm sure a lot of videos have done about captive nuts and things like that, but this is a Sunday morning fix, and in fact you can use it all over the place. But the nice thing about this idea is it's compact. You can get into the tightest little corner, and as long as you've got, you can drill a hole, well, you can get one of these in. But this sort of limits how far you can get in. You're limited by the length of here, and you're also limited by the length of the stroke of this. You can't quite get in. So I'm going to do a demonstration now of showing you what you need. So obviously you need some captive nuts. Now, again, this is one of my bugaloos. I like the metric system because it's standard, but here you have all sorts of different drill sizes and stuff, and even I keep one of these in my drill box because I don't know what the hell the sizes are at the moment. The size for this here, for drilling the hole in the metal, is 32/64, which I agree everybody's got in their toolbox, except for me. So the only nearest drill I've got is an 11/32s. Again, everybody's got one, come on. So It's a real farce. So what I've done is I've drilled a hole in a piece of metal using this 1132's drill. Now, in a way, that's a kind of a good thing, because you want these to be as tight as possible, and it is a little bit too tight. So what I'm going to do is, on the job I've just done, I actually just took a hammer to them and banged them through, because it's aluminium, this piece, and it's quite soft and it'll go through. I mean, 1/64 of an inch isn't going to be much of a difference. So what I'm going to do, I'm going to set this up and I'm going to bang this rivet through, this captive nut through. Again, if I had the right size drills and everything, would be great, but I haven't. I mean, I could die grind this out a little bit, but there is a chance of it going through. So I'm just going to tap it in, and there you can see it's just scored a little bit on the outside. It's no big deal, it hasn't really damaged it too much. So I'm going to try and see if I can do this real time. I don't know, let's have a go, it could be fun. I like a lot of fun. So we're going to clamp this in here. And then, with a bit of luck, which I've probably lost my spanner, right, there it is, I'm going to tighten this down. But I just thought I'll do it from the other side, and then you can see the nut actually being compressed. Let's move the camera around. What a lot of fun this is going to be, eh? Ah, dear me. So I hope you can see that. Let's zoom in a bit. There we go. So then you'll have an idea what goes on at the back side. I'm keeping it live, don't worry. The less editing I can do, the better. So I hope you can see that. So what I'm going to do, I'm going to hold the big nut at the back with a spanner. Let's just undo this just so you can actually see. Okay, so we've got the bolt and we've got the piece here that's all chewed up with a chisel. I'm going to put that through. Put the spanner on. And then the only one I'm turning, you can see I've got this one fixed. The only one I'm turning is the quarter, well, the 7/16. And you can see what happens is it starts to compress. You see that? Look at that. Isn't that wonderful? Starting to get a bit tight now. And that's it. You won't get it any tighter than that. Then we can take that out. It's not very often you see what goes on at the other side. Where are you going? Where have you gone? So you can see what's happened. It's compressed just on a small area. Let's see if we can zoom out again, because you're getting a bit tight there. So you can see there it's compressed on a small area. The reason for that is, I don't know if you can see inside that tube, the thread is actually just at the little bottom bit here, it's not in the top. See, if I put the bolt in, you'll see how far it goes in before it reaches the thread there. So that's where the thread is, just about there. So the thread's right down at the bottom, and it's got a crumple zone or a crush zone in here. That means you can tighten it up like that. Now, they are quite practical. I mean, you know, they're a lot better than some means of fastenings, but sometimes you screws and things like that, well, they're alright, but like on Land Rovers, they tend to vibrate. Now, these are nice and tight. If you can see here, you can see on the head of the rivet where that that nut has clamped onto the thread of here. Now, I must admit that one didn't go in too well because there was a slight burr of metal on there because I didn't have the right size drill, and I'm doing this video as a rush because I want to get on with my job. But you can see where the metal's compressed, and you can also see by looking inside that rivet there compared to that one, you can see the crush zone has come right far forward now, so it's going to work. And for hanging something like this on, it's going to be perfect. So I hope you like that, and if you want to use that, you can have that on me because it's a really good little tip and it gets you out of lots of little problems sometimes. Talk to you later.